Hey everyone, so my name is Thomas Brown, and today I would like to talk about wildfire prevention with artificial neural networks. So this is my capstone project for Flatiron School, and this project is for state and local governments in order to prevent wildfires. So here's the issue. Over the past 12 years or so, there have been over 12,000 wildfires in Washington. And obviously, that's just Washington. You know, California has huge issues, Oregon has huge issues. It's been especially bad this year. Millions and millions of acres get burned across the country, and across the world. Brazil had those wildfires in the Amazon. Australia was like mostly on fire this past year. So it's a huge problem. And arson accidents are increasing, and it's something that we need to take control of as a country and as a world. So for this project, I thought it'd be cool to build a tool that would basically look at satellite imagery and tell you if an area is at risk or not at risk for wildfires. So the way I went around doing this was I used the Google Static Maps API to collect images of areas where there have been wildfires. So I had roughly 12,000 latitude and longitude pairs where the Department of Natural Resources for Washington has verified that there have been wildfires there. And I fed that into the Google Static Maps API, and I pulled 12,000 images. This is obviously just a sample of 4 of the 12,000. So each one is zoomed out as far as I could, where you're still able to see individual trees and features. I thought that was a good level of balance of zoom and resolution. So then, obviously, if you want to train a network to distinguish between two types of areas, you need something to compare it against. So for the non-wildfire areas, I still wanted to keep it in Washington, just as more of a challenge. I didn't want the network to recognize between Washington images and non-Washington. I wanted it to recognize between wildfire and non-wildfire. So for the non-wildfire images, I took an additional 10,000 randomly generated latitude and longitude pairs that are all within Washington state. And I fed that through through a Python loop that would download, pull API images from Google Static Maps and download them. This is a sample of 4 of the resulting 10,000 images. I didn't end up using all 12,000 and 10,000. I think I used about 10,000 total between the two of them for my final model. So it's okay that there's a slight imbalance there. But as you can see, sometimes it's kind of obvious, like this is high risk of a wildfire. Sometimes it's less obvious. Like this, I wouldn't really guess is a at-risk wildfire area, but same here. Like this could be wildfire, maybe it's not. Some of these are more obvious. Like this obviously isn't having a wildfire anytime soon. So anyway, moving on to the solution. So we have the satellite imagery. Some locations have had wildfires, some have not. And basically what I wanted to do is build a neural network or a machine learning solution of some sort that could take in this imagery and tell you what the risk is for wildfire. So with that, a state or local government could feed in a much heavier pipeline of satellite data, maybe from NASA or a more robust satellite imagery service, and it can display an entire map, and it can show hotspots maybe where there are at-risk areas. For the model, I used a convolutional neural network, and it distinguishes between wildfire areas and non-wildfire areas. So the way a convolutional neural network works is it basically scans an image. You can see there are 3 layers here. There's red, green, and blue. That's just how color images are made up. And each layer is fed into a system, and it uses what's called filters, where it basically, it just scans the image piece by piece. And these filters over time, as the network trains and learns, basically, they can learn to detect edges, different types of features, different types of colors. So maybe the model could learn that, like, okay, if there's a lot of brown in the area, then maybe that means it's drier and more at risk, or can recognize trees versus cityscapes. So At the end of the day, I got some pretty good accuracy. I think my ultimate accuracy was around 70% for the test set, which isn't great, but it's really not terrible. Wildfire recall was almost 78%, which is pretty good because it means, of the wildfires that I fed into the system, it recognized 78% of them. Precision was a bit lower at 63%, but that just means that we had false positives, which in the case of wildfires is okay because, better safe than sorry. Obviously, you don't want every single image raising the flag, but you do need to be careful. So I ended up having a rough example of deployment for this product, where you enter a latitude, enter a longitude, and it tells you what the risk is for wildfire area. So this image actually came from California. It was an area that had a wildfire. So it came from California, so it's not something that my model had ever seen before because it was just trained on Washington images. And this is an area that, again, had a wildfire before, but the model didn't know that, and it correctly identified that it's super high risk. I'd classify 87% likelihood that this image is associated with a wildfire is pretty accurate. And this wildfire just happened like last week, so this image was taken well before the wildfire. So the model works pretty well. It's got some work to do before it's really deployable, but it's pretty good accuracy and it works. You can feed in images and it'll tell you if it's high risk for wildfire or not. So in the future, I would just love to have a much heavier pipeline of data going in. So I know NASA has excellent satellite feeds. Google has some different map satellite imagery services like Earth Engine. They have a few others. And I really just want to be able to build a tool where state governments can just have a continuous pipeline of satellite imagery running through, and a system where it'll raise alerts where it says like, hey, there are like, say 50 square miles right here that looks like, a tinderbox virtually, and you need to get a handle on that. And hopefully they know about it, but sometimes they don't, and that needs to be taken care of. Anyway, thank you for listening. This was my capstone project for Flatiron School. Special thank you to my amazing cohort and my amazing instructor. And please just direct any questions or comments you have to thomaskbrown18@gmail.com. Thanks.